I have a new games console. This is a Alps ActionRider electromechanical game thing. I found this at a local Brocky house for 5 francs. It dates from about 1980. While it does work fine, it is extremely crunchy and loud, so I thought it would be fun to take it apart, lubricate it, and find out how it works. So before I take this apart, I should probably demo it just in case I break it. This involves filming the screen, which is rather difficult. I have this extra light hooked up, but even so, it's quite difficult to see. Even more so from my angle, because all I can see is the reflected light. So the thing runs off 2 AA batteries, although not for very long, as it consumes about half an amp. So I have this 3D printed battery eliminator. So we stick the batteries in, turn on the power. Oh good, nothing bad happened. And now I can show you how it works. You are this character. You are racing along a track. You can move your character up and down using this. And the goal is to last a full minute on the track without running into either stacks of tyres here or the other cyclists. And the way it works is you turn the timer to start. It thinks we've crashed because there's another cyclist there. So I press this and I've crashed again. And so on. The controls are not easy. There's this, which is the brake. This stops the lower band from moving. Every time you crash, you have to press this to continue. This is the number of lives you've used up. And so on. And you can see the timer here has reached 30, I think that's seconds. The 2 bands move at different speeds, as you can tell. And so on. As you can tell, it is very loud. That's because it's all mechanical. My belief is that there are only 2 electronic components in this, and one of them is the LED, and the other is the resistor that runs the LED. Everything else, I think, is going to be one electric motor and probably a bunch of switches for doing collision detection and so on. But you've seen and heard it running, so we'll see if it behaves at all differently once I'm finished with it. Let's take the lid off this thing. So I've been unable to find very much about this at all on the internet. There is a logo here for Alps. They're the people who made it. I think that is the same company as the Switch manufacturer, but that's about it. They're not very rare. There's a bunch online for sale in better quality than this one, but actual concrete information, almost nothing. The fact that this was made in 1980 comes from a single story I found from a Hungarian family who were very excited to get one in the pre-Iron Curtain days. But anyway, I've taken the screws out. Have I taken the screws out? Yes. I need to remove the steering wheel. And now will the lid come off? It will. And there are the works. So this is a rack and pinion thing for moving your character up and down. It's hitting a stop. There. To stop me going into the lower lane? I think it's... Oh, probably because I'm colliding with that. So this one down here must be similar. We've got the timer. This is the live counter. That means you're dead. So you set it to 0 to start the game. Here is the brake, which moves a little thing in there. Let me put the power back in, shall I? Okay, so we turn on the lights going. If I push this, so this metal thing here popped down, so it's blocking the motion. You see the cams here popping up and down? I'm not sure what they do other than stopping the motorbike moving, to be honest. Ah, this has gone to off. So I need to put that back to on to make it move. Yes, very odd. I can't tell what these are actually for. Anyway, looking at this, these two strips contain the actual track, and there's a slot here. And I bet that, and probably these holes, have to do with it knowing where the various obstructions are. They are quite scraped up. I am going to do another bit of disassembly. I think we need to take some more stuff off. Not with that screwdriver, I'm not. Makes a good smell of ozone when it's operating. I don't think that motor is in very good nick, which you can just see in there. I'm actually a little worried about taking it apart too much in case I manage to hideously break something. Oh, that's interesting. You see the light in there? That's not red. I think that's a light bulb. You know, an old-fashioned incandescent job. So, after removing the right set of screws, this whole unit here comes off, revealing the works. Those spikes go in the slots here, and that is how the thing knows whether the player has collided with something. Inside these holes, there are copper contacts which touch these and close an electrical connection. So there's clearly some logic involved there. I mean, very, very basic logic. There's a wire that runs from here to the timer, which is the on-off switch. In fact, you can see down here these copper pieces. Hopefully that's in focus. And if I turn that to off, no connection is made. If I turn it on, you can see it move and the connection is made. This, by the way, should be soldered on there, but it came off. Down here, this is the main gearbox, which has got the motor, a whole bunch of gears to step stuff down, and the clutch mechanism for this thing. You can see the thing moving. The two strips here are driven by these two cogs. So this one moves the top one, and this one, it's a little hard to just turn this and not the other one, moves the bottom one. And the bottom one is also wired to the timer. I say wired, but it's a bunch of worm gears and things. So the entire gameplay is controlled by the position of these slots, which are placed so that if I move it to about here, the player will be colliding with those tires. So the slot is now opened up the the way to the copper contact, which allows one of these things to pop up and do stuff. But let's just put this somewhere where it won't make contact with things. And let's apply some power and see what happens. Power. Okay, nothing's happened. So we are getting power. I'm going to solder this wire back onto this thing, because I think that the logic won't work without it. I have reattached these wires, and also this black wire here came loose while I was working on it, so I've reattached those and replaced some of these with longer ones for convenience. So, power. Okay, nothing's happened. Do I have to press both of these? No. Do they need to be touching this box up here? Aha, light goes on. Push this. There we go. And I think the switch here isn't working quite right. Yeah, this cog here isn't quite making contact with that gear in there, because they are very close together. Like so. Right, well, I was hoping I could make this thing work without this on it, because I kind of want to... Oh, it does work. Excellent. Well, now I can tell that most of the noise, let me try and get this on camera again, is coming from this gearbox down here. All right, what's changed? Interesting. It's behaving like the battery's going flat, but of course there isn't one. Okay, this needs some more investigation. I've reverse engineered the circuit diagram of this thing, and as expected, it is not very complicated. There is a battery here inside the battery compartment, and there is the motor here inside the motor compartment. There is a light bulb, which is in this yellow box, and there are 4 switches. The first one is the on-off switch, which is part of the timer score mechanism here. Then there is the recover from crash switch, which is activated by pushing this. This also moves this purely mechanical life counter. It doesn't actually do anything, it just goes round. And then there are the 2 sense switches, which are these things here, which control the game logic. The way it works is that normally these are pressed down by the plastic strips. That closes a circuit from the battery, through the switches, through the motor, back to the on-off switch, back to the battery. So it goes round. When you run into something, one of these things pops up. That breaks the connection to the motor, so the motor stops. And then this point touches one of the copper pads in the yellow box, and that completes the circuit to light up the crash button. You recover from the crash by pushing this. That closes the circuit this way, which runs the motor, even though the sense switches say that you've crashed on something. And then once you've recovered, you release this and the gameplay continues as normal. It knows where you are because of this thing. This is the mechanism that moves the rider, which I've pulled off to make things clearer. Normally, both of these are pushed down, and you can move up and down freely. These little plastic things stop these things from popping up. When you are in an area where there is an obstruction, but you're in the other lane, then this happens, that overrides this, and the gameplay continues. It's kind of unintuitive. Remember that in this position, the rider is at the top. So this is actually controlling whether you run into the lower obstruction or not. Because, of course, if you're in the upper lane, you're not going to run into something in the lower lane. And then, of course, you move to the other lane for the other obstruction. And now this one is forced down. It is actually fairly intelligently and cleverly designed. So now I understand it. We can make it go rather more reliably. First, I rotate the timer so that the on-off switch is in the on position. And now I press both of these down. And the game thinks that I am not hitting any obstruction and the motor runs very noisily. So I think the next thing I want to do is to take the lid off the gearbox rather carefully in case something goes sprawling and all the springs and gears go everywhere. Okay, this is also a fastener screw. And there's also a little springy thing here for holding this thing in position. So now this should lift off. I have no idea what that was. I found a few things on the floor. This seems like the most likely, but we'll see. I also didn't find a spring. Seems like a bad idea. Okay, anyway, that seems to have opened, revealing the gearbox. And it's basically a lot of step-down gears. It's not a very quiet motor. I have some light lubricating oil, so let me just stick a few drops into the everything. I'm wondering if I dare lubricate the motor as well. Yeah, let's give it a go. Oh, that's so much better. Let's just do the other end. Why isn't that running? Something has got jammed and this isn't making proper contact, but if I push this one, then it does run. And is nice and quiet. Okay, so what was the thing that went sprawling? There needs to be a spring here. This is the brake. When you pull this, this is supposed to move down and disconnect one of the strips from the motor. So I bet there's a spring in there. Is this thing even slightly related? Oh, this will be the thing that the spring will have been pushing against. Does that fit on the shaft? Yes, it does. I was unable to find that spring, which is presumably somewhere on the floor in my study. But luckily I have a box full of spare springs and this one seems to be about the right size. So let's give this a try and see if it works. Now, I think the way this is supposed to work is that this thing slides on first and provides a smooth surface for the gear wheel to rotate on. And then I put this spring on here, pull it back and fit, let's try that again here, pull it back and fit this into place like so. And then try and put the other gears back like so. So That seems to be going round. And does this thing still work? Oops. To make sure it doesn't ping out again. So what that spring's supposed to do is to push this gear back when I pull this. This has got its own spring for returning it to the forwards position. I think that is working. And put the lid back on. Why isn't this going on? Yeah, this keeps popping out. No, that is right. The spring isn't sticking out above the rest of the works. So there. That's it. So now the lid is back on. Let's see if this sounds any better. It does not. It is in fact just as loud as it was before. Which is annoying. Oh well. Now let's take a look at this bit. It'd be nice to be able to get this apart because I want to take a look at these plastic strips, but there don't actually seem to be any screws other than these which hold the yellow box together and are underneath the plastic. This axle seems like it will push out. And come loose. I managed to short something and the power supply turned off. I shouldn't really be doing this with it turned on. So yes, this does pull gently out. But I also want to be careful because I want to be able to put this thing back together again afterwards. There we go. So what do we have here? Two rubberized wheels. This one turns this wheel and the outer one is connected to this wheel. So there's actually nothing particularly of interest there. Now we have this and the plastic strips. They just come off like so. Revealing another set of rollers, but this one is rubberized and this one is not. Why is that? That one rotates freely, while this one is connected to this gear here and turns the score wheel. Let's take a look inside this box. That just lifts off, revealing copper contact and a light bulb, and it's not even in the socket. That would be a pain to replace. So let's just put that back on again. If the light bulb were to go, the obvious thing is to replace it with a red LED, which would of course need a resistor. The reason why it'd be difficult to replace is that the wires are bonded directly to the light bulb. Okay, these strips, which are rather badly scored, they are stuck together here. There's 4 holes, but I think those are to do with manufacture. And we've got the plastic slots here for collision detection. I would very much like to scan this, but to do that I'd have to cut it open, and I really don't want to do that. I would not get it back together again. Okay, let's put this back together again. It's actually seen quite a lot of use. These strips are fairly scraped, and you can hear them scratching against the whatever it is they're scratching against. Maybe it's this wire, actually. No, it's not. There's little dents and dings and it's all over the place. Someone clearly played this. All right. Power. We have crashed. Push the button. That feels like it's jammed on something. Ah, it's on this. This thing here is supposed to be underneath that metal thing. So in fact, that is poking up into the plastic and is probably not doing it a whole lot of good. No. There's something wrong here. This is not moving up and down. Ah, that's better. Yeah, easily sorted. It just needed a bit of jiggling. If you don't put at least one of the screws in that holds this assembly here on, then this thing twists sideways a bit and then this doesn't line up with the slots. But if I push the button now, you can see them both pop up and down like anyone's business. So the carrier for the character goes in here. The capstan for the steering control goes in here. I'll actually add a bit of oil. And here, actually. Just to make them go around a bit more smoothly. Like so. And this thing, after I took the wires out of the way, goes on here. And that should hold everything together. Okay, so if I rotate the wheel now, it should actually play. It's quite crashed, so it should be playing. Okay, that's not fastened down very well. I also realise now that I forgot to put contact cleaner on any of those copper contacts, so I'm going to have to take the top off again. No, there is still something not right. It should be playing now. We've not collided with anything. At least, doesn't think it's collided with anything, although this seems to be down. That should have popped up. Interesting. Why has the light gone out? I don't think this is making contact with the lighting block, because this is how the light gets its power. This thing pops down, the other side goes up and sticks into the copper pad on the lighting block. Is that a light in there? No, it's just a lump of something on the plastic. Turns out this screw doesn't hold the cassette down. It just holds the cassette together, so that I only have to take out and remove these 4 screws every time we need to do this. So that's nice. I'm really not sure it's supposed to be doing that. I suspect that now I've lubricated it, there isn't enough friction to make the motor come to a halt while you're still on that obstruction. So it rolls forward a bit, comes off the obstruction, and then the motor kicks in again. But it does at least now seem to be working. Wait a minute, why isn't the light on? So with the rider in the fully up position, that means our player is now on this track. So any obstructions you hit on this side are masked out by this plastic thing preventing this from popping down. Now, the motor's not running because we've collided with this and this thing has moved, but it hasn't moved far enough to engage the light. Yeah, if I push it down, that engages. So we then hit the same obstruction and stop. We haven't hit anything. So is this not right now? Yeah. these aren't going up and down far enough to either make good contact with the light box or make good contact with the two switches, these that make the motor run. I wonder if that's the contact cleaner I put on it. It wasn't doing this before, I think. That flicker's not good. The other thing that could be happening is that if the power supply from the battery to these things isn't good, that would do it. So, are we seeing voltage? Yes, we are. So it's not making contact with the motor switches. So the two switches, this one provides power to this copper thing from this wire running through this and onto that. So if I push down, the motor runs. Now the motor is not running. Why is the motor not running? It wasn't running because this wasn't pushing down hard enough. So one thing that you can't see on the camera is there's actually a felt pad under this that prevents this from making contact with this copper thing. Instead, when this comes down, it pushes this copper thing and this together. And one thing that makes things even more annoying is that these slide up and down and the little spring springs out. There's not very little holding it all actually together. There is a broken plastic thing. Oh, I know what's happened. This has broken and this axle is misaligned. It should be down there. So let's apply a couple of drops of super glue. There and in here. And push this back into place. And then just sit back and wait for that to set a bit and see if that helps. So let's see if this works any better. Oh no. Oh no. The only reason I was able to slide this thing down past this plastic nub was because this axle was too high. Fantastic. So I'm going to have to break it again, slide this thing up, and then glue it together again. So and I also don't really want to super glue this thing into place. I wonder if there's a better way to. Of course there's a better way to do it. Hot glue. I really should have thought of this earlier. I can stick some hot glue in here. And once that's set, it should hold the axle in place. And this thing will still move. This thing will still move. Oh, hell. The hot glue has gone under here and has stuck this thing in place. That was not very well executed. So the problem is that this is soldered on. This washer here is what holds the axle in place. The other end is just a blunt end. So the only way to actually get this thing in and out is to slide it up and down. So yeah, clearly this thing is now fastened to the axle, which we do not want. So let's just try levering here. Oh no, that won't work either because there's the plastic knob underneath. So you see, this moves up and down and doesn't rotate the axle, but this does. This is the end that won't come off. So Do I unsolder this? I suspect some super glue has got into the gap between this thing and the axle, and that's why it's so firmly in place. I don't think that's hot glue. There we go. So now this will slide more freely. And this is really well wedged. No. So if I squeeze here, I should be able to get a decent amount of force in while keeping everything lined up, more or less. No, that's not going to work. Completely balked. Fantastic. It was very nearly fixed too. Now let me clarify. There was nothing wrong with it before I fixed it. I am going to have to break this. Damn it. There we go. Broken. So looking at the underside, this is the lower lever. You see here's the felt pad. Well, this is the upper lever that is now solidly glued to the shaft. So really I need something that will let me push this against this, like a stud puller. Is that the thing you call them for pushing shafts out of very tight bearings? I mean, much like this. Well, that piece of scrap metal is bending, but I am getting the force in. I'm not convinced this is working. This is so firmly attached that I'm halfway convincing myself that it was always fastened to this shaft, but of course it wasn't, because this was sliding up and down. This is only aluminium. It's just a piece of scrap I found lying around on my desk. I'm sure I've got some steel somewhere. Okay, I have a monster piece of metal that was actually part of a piece of, I think, IKEA shelving unit. So let's just arrange things like so. Right. It's moving. And I don't think I can push this any further. Wait. Ah, that has come loose. In fact, if this will focus, you can see that when I turn this, the shaft is not going with it. So I should be able to use... Yeah, it's coming. Okay. And now I push the thing back in, and it neatly pushes all the super glue out, and now it moves again. Not very well. That's, oh yeah, there we go. No problem. So the center of the shaft is now kind of scored up, so it doesn't slide up and down very easily, but it is now no longer super glued. So the next problem is how I can get this fastened down. There's the other spring, by the way. Is how I can get this fastened down here. Now that the mounts for the central axle are no longer in position. Well, with luck, my 3D printer will come to the rescue. These are replacement holders for the axle thing. They will go in place of the ones that I broke off and get fastened down. And hopefully, if I've done everything right, they will hold everything in the right place and it will continue to work. So the first thing that needs doing is I need to get the remainder of the old holder things, whatever these are called, off. That plastic is very brittle. Okay, that was much easier than it really should have been. So now let's try putting this lot together and see if it all fits. So with all these sliding on in order, this one goes first, then that, and then the last one. And that will go down approximately here. I think that will largely work. Okay, I'm going to use hot glue for this so I can get it off again easier when it inevitably doesn't work. Let's just put a blob here to tack this in place. And stringy stuff everywhere. And there. So let's just let that set for a while and then see how well it all, works. That looks reasonable, actually. I think it's reasonably well centered. I think these things are in the right place. So let's reassemble it briefly and see if it works. Okay, now this thing needs to make contact with this bar pretty well, and I bent it somewhat getting it off. So need to bend these little tabs back in. I think it just pushes on. I don't believe it was soldered to the bar, axle, bearing thing. There we go. I think this is just a friction clip. Now the electrical contacts. This one goes here, and this one goes under it. Luckily there are these little plastic spikes that hold it all together. Wait a minute, that's not right. Has that bent? Oops, that was not good. They're actually a lot thinner than they look. So that goes in there, and then there's a little screw which holds it in place. It's weird. I think I got this free in a Christmas cracker or something, and it's incredibly useful. Okay, where are the other screws gone? So now this bit, this goes on here. These need to get pushed up. It's all fiddly and very awkward. Nothing's actually hard, just fiddly and very awkward. And the weight of these pushes down on these, which I suppose it really ought to. Let me find something to hold it down with. That's better. I don't think the weight of this is going to make electrical contact there. So possibly this copper thing here might need bending, but we won't know that until I've actually fastened it together with all the correct screws. Okay. Not so hot. Now it is possible that the plastic strip will help and push that down. That broken badly. The screw here has wrenched out of the plastic. This is supposed to go in here. And the screw holds it down. Is there actually anything left? Oh, there is just enough. So let me hot glue this together just to hold it. Said hot glue. There we go. Okay, let's see what happens. Power. Have I forgotten anything? Don't think so. Right. It's reasonably solid. Yeah, this isn't making contact. Closely working. Yep. Anyway, this is now aligned properly. Ooh, it's this one that's being problematic. Interesting. Maybe it's not aligned very well. I have this terrible USB microscope thing. The resolution's awful and the focus is equally so, but you can actually make out the two metal things. The further one is this one. You see it jiggle, which is pushing up against the yellow box and therefore the light's on. The front one is pushing against the plastic. So if I wind the thing on a bit, this button, the back one has popped down and the front one has popped in. And the light is on, but dimly. I'm not convinced that this thing is made contact with the light bulb. I think something else is going on. So let's just check the voltages. Nothing. Unless I push. Right, I think this is not making proper contact with the axle, or the connection from the battery to the axle isn't making very good contact. All right, what have we got for voltages? Wait, why are we not getting anything from this? I turned the power off, that's why. Okay, 3 volts. 3 volts. 3 volts. 3 volts. That's 3 volts. That's nothing. That's 3 volts. This connection's bad. So I push on it, it goes to 3. Okay, well, that does need fixing. But for now, let's tackle this. This is 3 volts. This should also be 3 volts. If I push this down, what's this? That is 3 volts. No. Yes, okay. I don't think this is making good contact either, so I think this needs to be bent up a little. 3 volts. Okay, I think that's better. I'm not sure about this. Very intermittent. Chances are there's still some super glue in this joint here, and that's why it's not making good contact. So what can I do about that? I suspect that this stuff will be impossible to solder to, otherwise I just run a wire from either here or the battery terminal up here to this thing. Possibly all it needs is working until whatever is preventing it from making contact wears off. I mean, it's already better than it was. Well, I have spent a lot of time jiggling, poking, bending, contact cleaning, generally hoping, and I've come to the conclusion that I cannot make this work reliably. The copper pad's just not making very good electrical contact. I suspect this could be something I've done, but I also suspect this never really worked very well anyway. So I think that the switching system on this is basically a write-off. And that's why I made this. This is a replacement assembly for this thing that replaces the little copper contacts that I have taken off this and probably lost with microswitches. So this should hopefully fix all the electrical problems. I also make this. Yeah, that's quite a lot of wasted plastic. Still looking for a way to recycle this stuff. Let me show you how it works. There's not actually an awful lot to it, but it did take quite a while to design. I went through a lot of different iterations, as you could tell by that pile of plastic. So this is the original slider mechanism for the character. It's just screwed on. The slider runs on a little track, which I have replicated in the 3D printed piece. We have the original levers and axle and so on, except now these are not electrically active. The little clip here used to have the wire attached to it, which now doesn't. It fell off while I was working on it, but I wanted to take it off anyway. This lever pushes down on this microswitch, which is just glued in, and the microswitch does the switching. This lever has to work differently because there's not enough clearance here for the microswitch, so I've had to move the microswitch up here, so the other end of the lever is pressing it. That means I need a return spring, which is in there. And we have contacts on the bottom that need wiring up in the correct way. And hopefully this will solve all my electrical problems. This should not actually be very complicated. If we look at the circuit diagram, we see that the positive terminal of the battery connects through both switches to the motor. Well, here's the positive terminal of the battery, here are the two switches, and here is where the motor is connected. So we just need to connect this wire through these two switches and this wire to something. That should make the motor operate. The lighting we'll get to in a bit. So just to make things a little bit more complicated, because this switch is on the wrong end of the lever, it is normally made, but if the lever is pressed, it disconnects and becomes broken. Well, this is the other way around. It's normally broken, but when pressed, it makes the switch. But luckily, both these switches have make and break terminals, so I just need to figure out which is which. Now, where am I going to put it? Well, it has to go here on the pads, and I need enough slack to actually work with, so this is going to involve lengthening the various wires. So that's now connected to the common terminal of this switch. I now need to find the make terminal. So if I test continuity from here to here, I get nothing. Here to here, I get a beep. Okay, so this is the break terminal and this is the make terminal. If I connect this and then use my third hand to press the switch, it beeps. Okay, so all I need to do is connect from here to the common terminal of this other switch, which is this one. All right, and now let's just remove some of these tangled wires. Now I need to connect this to the brake terminal, which should be the one on the end. So now I should, assuming it works, be able to apply the power and see the motor run. So, power on. Okay, let's push the switches. 1, 2. Nothing's happening. Why is nothing happening? This is not a complicated device. Maybe it would help if I remember to plug it in. Push switch 1. Push switch 2. Yep, the motor runs. That's great. Okay, so we've done half of it. The other half is the lighting unit. And for that, I'm going to have to take this thing apart because we need to solder another wire to the lighting box. Originally, of course, the two levers would have made contact with the other side of these pads to close the circuit to light the light. But we're not doing that anymore, so I need to solder an extra wire on. Okay, all right, here is the game cartridge reassembled with the wire hanging down. So I think it actually wants to come through here, and I shall just stick it down with a dab of hot glue. This is going to be connected this way, so this wants to be connected to this terminal. I wonder if that wire is in fact long enough. All right, let's try assembling it like that and see what happens. So that. This, I think, needs to be moved to be on the other side of this wire. Well, here it is all put together awkwardly, and the red light is on, which is nice. Let's run the motor. Okay, off. Only one of the switches is hooked up, but I now can't remember which one. Okay, why isn't the top one going round? This isn't working right. Something is wrong. Oh, I know what's going on. So because I only connected up one of these terminals, this switch doesn't get power unless this switch is made. So if I actually hold down that switch, light comes on. Because that way power is reaching here, that's then getting routed through to the light. Okay, so I actually need to install the other wire, the thing that makes this into an OR gate. And my hot glue's come loose. The thing I like about hot glue is it's easy to take off. However, this also means it's not very good glue. And because I forgot to turn it off, you can see the light went on when I soldered that all together. So now if either switch is up, the light comes on. Right, so I think that should all now be working. Well, the bottom track works quite well. The top track, not so much. And there's actually a score mark running along there. So I wonder if this is actually pushing up too hard against the plastic. Ah, that's a pain. The electrics all work, which is nice. So using the nasty little USB microscope thing, that is the lever for this side. So if I run it, yep, that is too tight. Well, blast. That's the microswitch. And it's not flush. It should be a bit further down than that. I put it in the wrong place when I hot glued it back in. So it's pushing too hard up against the plastic film and is both scoring the film and preventing the thing from moving through friction. Now, how well did I hot glue it in? Quite well. I'm going to have to take this thing off again. Okay, that is now recessed very slightly. So now I get to put it all back together again and try it again and see if it works. I've been doing a lot of this. No, wait, here is the problem. In slightly blurry, horrible USB microscope vision, the microswitch is hitting the bottom of the case, and that is what's pushing it up. I've just run out of space. Okay, this, I believe, needs me to bend the pins on the microswitch. We only need a tiny amount of space. So it's kind of hard to see, hence the pokey stick, but there is actually clearance there. So that should hopefully work better. Pushing the button. Okay, let's put the character back in and see if it will play. Yep. What did I hit? Both levers are up. That shouldn't... Now this isn't being pushed down far enough to engage the switch. So if I move this thing manually, yeah, It needs a little bit of a, it needs a bit of a bend. Ah, it's now too high. Yeah, there's not quite enough travel in the position of the lever and the microswitch. So that if I move it any further down, the lever doesn't move quite far enough to engage the switch. But if I move it any further up, then the lever presses into the bottom of the film and stops it from moving, as well as leaving that ugly score mark. That's not moving far enough. So I think I know what I have to do, and I don't like it. I'm going to have to move this microswitch further along to the left, because that means that there will be more travel when the lever moves. Only a little, but hopefully it should be enough. Since I was printing it again anyway, I took the opportunity to do a bit of an overhaul. So it's now thicker and stiffer, so hopefully this should wobble less. There's a mount point for this tensioner thing that pushes up against the bottom of the loops as they go around, which I think helps them get traction on the rubber thing here. And I also made the two microswitch mounts friction fit, which is a good thing because I'm going to have to adjust these a lot. So the issue is that this microswitch here, there's actually very little clearance between the point where it actually clicks and the point where the lever is pushed all the way down by the film. If I mount it any further down, it won't click. But also, if I move it any further up, then this side hits this microswitch, which isn't really a problem unless I need to adjust this up. So there is a possibility I will have to move this microswitch, rotate it round so it's at an angle so it misses this lever. But yeah, I think this is going to be very tight. So I think the only thing to do now is to put it all together. Oh, blast, this thing's fallen off again. The plastic here is broken. Is to put it all back together and see if it actually works. Okay. Well, that one's working, but you always knew it did. This should be going round, shouldn't it? That means the microswitch is too far up and needs pushing down. Luckily, it's friction fit. I think it's actually working. That's amazing. Why did I run into something? All right, the top lever is in the channel. The bottom lever is pushing against the film. So normally the top lever would be in the channel pushing against the lighting box, indicating that I've run into something. This block here is supposed to be preventing this end from going down. This end will go down when the lever goes into a slot in the plastic. And you can see from the fuzzy vision that one end of the lever is actually in the slot in the plastic. Without this, that should be pushing against the lighting box, indicating that I've collided with something, but this is supposed to stop that happening. So I think what's happened is it hasn't quite moved the switch far enough and it's not gone click. So if I lever it a bit, see it move the lever. Yeah. So yeah, the switch now needs to go up a little. But you can see from the top of the lever, it is very nearly touching the plastic, so it can't go up very far. Luckily, it's friction fit. So I've moved it very slightly. No, that's still not working. I moved the switch just far enough so that it clicks when it's resting on this thing. So let's see how this behaves. Clearly I did not move it far enough. Nope, this is not working. If I move the switch far enough that it clicks when the lever is pushing against this yellow thing, then it's pushing so hard against the film that it won't go round. I am going to have to rethink how this works. So I made this, and this nearly works, but nearly is not quite good enough. I rotated both microswitches so they're operated by this end of the lever, and because the axle bar here is pushing against the switches, I ended up having to move the switches down, which means I needed these plastic shims. But unfortunately, I ran out of space between the microswitch here and the base of the machine. So this switch ends up pressing against the axle bar, and as a result, if I push the lever, you can see that the microswitch lever itself doesn't move because it runs into the axle, and as a result, it doesn't go click. So that's not going to work. This end works fine. Then I made this. This also does not quite work. I moved the microswitches so they are all to one side of this axle, which means they are not limited by how far they can move up and down. And as a result, this one now works quite reliably. Unfortunately, this one does not. Because this is now pushing against more or less the middle of the lever on the microswitch, with the middle of this lever here, there isn't enough torque to reliably push the microswitch all the way down. So it just doesn't click. It needs just a little bit more. And after that, I made this. This one has this microswitch moved up a bit, so there's a little bit more of a moment arm on the microswitch thing. And it does actually click on both sides. So this one might actually work. And go. Okay, we're successfully colliding with the lower set of barrels, tires, whatever it is. The same inertia thing that means it keeps skipping forwards a bit is still applying, but I'm not even going to try and fix that. Let's try the top track. That also seems to be working. Thank God. Okay, what was happening there is a bug where if this is pushed up too far, then this lower block that's supposed to block the collisions from the lower track from happening actually also blocks collisions from the upper track. And that's because this slider is going up just a little bit too far. But I don't think I need to reprint it. I think I just need to put something to stop the slider moving up. So here's the slider track, and this thing moves up and down here. And if it moves just a little bit too far, then it doesn't work properly. Luckily, I have a lot of bits of plastic from leftover prints of this thing left. So if I put one in here, now how far will this slide? Needs to go a little bit further. Let's try there. There we go. So now it can't move far enough for this thing here to get under this lever. So I will just tack that down with a little bit of hot glue and then reassemble it all. And finally, here it is, all working, I hope, and ready to go. Let me demonstrate. Set this to on, we're in the crash state, press this to start, and... and it goes on like that. So, after all my work on this thing, I believe it is now no more broken than when I got it, and possibly less broken. I suspect that it just didn't work very well out of the box. I'm sure there's a lot more tinkering I can do with it. Some things don't seem to work quite right, like I can't move the player any further down because there's a set of barrels here in the way and the player character is hitting the little plastic stop, which feels a bit strange, and I'm not sure that's intentional. But I'm going to leave it like this because honestly, this project has taken weeks and weeks of real-world time. I started this in November, and I really want to use my workbench for something else. One thing this has done is given me a newfound appreciation for the people who actually made this thing in the first place. This was 1980-ish. I would like to know how they designed it. Like, was it done on computers? Was it all done on drafting boards? Because there are a number of fairly subtle moving parts, like the rocker things that make the sensing work. And you need to get the spacing just right, as I discovered, or it just doesn't work properly. But I suspect I will never know. It is interesting just how much standards have changed with regard to fun games, because I figured out the strategy, which is to wait until the player is just in front of an upper track obstacle, brake, wait until there's space on the lower track, and then move down and back up again. You just keep doing that and eventually you will win. By modern standards, it's not very fun. But while it may not be fun to play, it was certainly fun to take apart. I think I learned a lot from this. And now it's going to go into a box in storage, and maybe I'll get it out again sometime. There are some things I could do with it, like some sort of backlight to make it a little easier to see what's on the screen. I can barely see it at all from my angle up here. But I am going to leave it there. I hope you all enjoyed this tour through this 1980-ish electromechanical game. I certainly enjoyed touring it, even if it did go on for a while. So, as always, I hope you enjoyed this video. Please let me know what you think in the comments, and I will see you all next time with something that isn't electromechanical. Probably.